Okay.
Looks like this took a lot more steps than your little Canon model.
Then the little cannon, it did. It's got more pieces, and so that did take more steps. So let me just, because I started the recording, let me just back up a little bit here, just to say that we're going to focus on sketching today, how to make sketches, and one of the things that I want to focus on is how to project geometries that are not necessarily on a parallel plane behind where you're sketching from. So let's say you have a part that's at an angle and you want a hole to line up to it, or you have something that needs to line up with another part that's not perfectly parallel. I'm going to show you some techniques to do that. So this little chair that I drew up is an exercise kind of in that, and we'll work a little bit on this, but we'll also do some sketching from scratch so you can kind of see how it starts. But a few things to point out on the chairs, the two sides are angled in from each other to make the base, where it sits on the floor, a little wider than the seat. The legs also angle forward and backwards a little bit, which requires the brace here to be at a little bit of an angle. The seat of it is at a 2-degree angle off of horizontal, and then you've got the slats which go in the back. And in fact, the slats, they all have to be a little different because the top slat, the notches for it, because it's kind of like a notch construction, the notches are closer together because the two tops of the sides are closer together. And so, Tiff, you were just saying that looks more complex than the Canon, and it is quite a bit more complex. It's got more parts, and then again, because of all of these angles. If I turn on some of the construction planes, just to show you, so there's a lot of construction geometry that I have. A lot of it is hidden right now, but I kind of started out by defining the different planes and angles that I was going to be working with. Here, if I turn on all the different construction planes, these were the planes I used for my different sketches. So you can see that I wasn't using necessarily straight horizontal or vertical planes for sketching. So let's start by leaving the chair alone for now. I'm just going to start a new design by using the little plus up here, or the first time you start Fusion, it usually starts with a blank page that says Untitled at the top, right? So it says Untitled, so this is a new one. I can check my document settings. It's in millimeters. That's fine for what I'm doing. The named views, I just have the stock views, which is fine. And then the origin, which is hidden right now, are the 3 planes and a center point to start from. So the first thing I'm going to do, because I want to show some multiple bodies or multiple things, I'm going to start by making a new component. I don't really have a name for it yet, so we can leave this name as new component. Although we could do maybe a little simpler version of that chair. So we'll make this the side. So it's a standard component. It's internal to this project here. External means it would save this component as a new component in your folder, in your tree folder here. So like if I go back to the Canon, right, I have different components for all of the screw and the base and all of that. So, but for this, I'm going to let it create the new component just internally. And then it says parent is selected as just the origin because that's where we're starting from. So I click OK, and so now the little dot is here next to side, and so this is the component that we are working in. So if I want to start with a sketch, I'm going to go to the Create Sketch button up here on the left, and when I click it, it's going to ask me to choose a plane or a place to start sketching. So right now I only have 3 planes, right? I have these 3 at the origin. If I want to, I'm going to hit Escape to not select one for the sketch, because I want to point out that there might be a time where you might want to start sketching that isn't on one of these 3 planes. You might want to make a construction plane first. So you would use one of these tools here, offset plane. An example might be, let's say you are going to make something, even like the chair, where the left side and the right side are mirror images of each other. You might find that you might want to create a plane offset from one of these planes, whatever half of your thickness of the chair is or your object, because then when you're ready to make the other side, you can choose the origin of this plane to be your mirror point. In other words, you can if you know that you're going to have something with two or more components, and you want the center, or kind of this original origin center, to be in the middle of the object, you might have to start drawing it offset from the center. So we could create a plane here and do that. If you wanted a plane at an angle, there is a tool under construction for plane at angle. And for a plane at the angle, you select an axis, and then you have a little rotate bar, or you could even type in a number, right? So let's say, for whatever, if we needed our first thing to, be at an angle to something else, we could create a plane at an angle and then use that plane for our starting sketch. And if you look in the under the our component here under side, you can see that there's a construction part of the tree, and you can see that we've created these reference planes, and you can hide them or not.
Well,
it isn't. Yes.
But you could start in the original
Yes.
plane and then just move it out later and mirror it, right?
You can, or you could always create a different plane, right? So we can do that. So we can hide these for now. We can start, say, sketching on this plane, later create another plane away from it, and then mirror it around that. It's more, I'm just bringing this up in case for there might be a situation or where you might want to keep this origin in the center of your construction as opposed to on an edge or on the side of your construction.
So if I use the origin plane,
I
can just move the item away from it and still keep the center.
Right, because this origin is under the parent. It's under the entire document here, and so this origin is going to be kind of your fixed. It's kind of like for CNC machines.
I understand it's fixed, but could
Yep.
you draw on that and then move the drawing, or you have to decide in advance where you want the drawing, how far you want that plane to be?
Yeah, so when you create a sketch, you define the plane that the sketch starts from. So if I define the sketch on one of these planes, I cannot move this plane in the future because this is part of the origin. This is the origin plane.
I got you.
If I, let's say, drew a sketch, and we'll draw just a real simple sketch to show the example, right? So if I choose this offset plane that I made, and let's draw a sketch, we'll do just a circle for now. And if I finish that, we can now create a little bit of a solid object. Oops. Create a little solid object, right? So we've created our solid object. And so this was started, from that plane. If you look here down in my history, we see that, this is the plane that I created. This was the second plane that I didn't use. And then this is the sketch. If you right click on the sketch, you can redefine the sketch plane. So I can say that, I want this sketch to be on this plane. And then it actually reoriented it. So now my little cylinder is starting right off from that plane because I told it that instead of referencing a previous plane, reference this new plane. If I undo that, so it's back, so I did Control Z to undo. So this is back at that first plane. If I go to the creation of that first plane and I want to modify it, I can go right click and go up to edit feature. I can now, say, hey, I want this plane to be way over here. And now when I click OK, it updated the things that were related to it, that followed it. So, I was able to, by moving that plane, move the sketch and move the part. So yes, if you did make a sketch on an origin plane and you then later wanted it to be in a new place, you could, reassociate that sketch to a different plane. But you'd have to create that plane at that point. So in my mind, try to think ahead a little bit and think about what you might want to do, first to start off. And that might make it a little easier. And it gives you a little bit more control to adjust it. It's easier to move a a plane that you created than it is to, then to create the sketch, then create a new plane, and then assign the origin to the new plane. Does that make sense, Tiff?
Yeah.
So, but I'm gonna delete these things, so we'll start again fresh. I will actually move this plane back to wherever it was or thereabouts. So let's we'll go back to that sketch feature. So sketch, let's create this plane here. And so if you saw before, when I made the circle, I just used one of these tools up at the top. So these tools have changed now that we're in the sketch view. If I finish the sketch view, these tools change to working with solids. If I go back to that sketch, which I can get right back there by double clicking it on the timeline, it brings it right back to where I had left off. So these tools are the sketch tools in the ribbon. And the ones on the left here that have the blue and the black, those are for creating different elements of the sketch. And then these ones that are kind of red over here in the middle are the constraints. And those are more for defining where things are. Interestingly, dimension is over on the left, even though dimensioning is kind of a constraint. And then the only thing you're looking at when you look at your sketch plane is you have your origin point, right? So this again is the center of the original origin. And as you do new sketches, if you do components that are on different planes or different areas from places, you can have a different starting origin for a sketch. Because if you look here in the tree again, you can see that this component has its own origin versus the origin of the original document. So you have the center point, you've got your two axes, the green and the red, and then you kind of faintly see those planes that we created before, right? So this one that's kind of more rectangular is plane 2, and that's that plane that's at a 45-degree angle back behind the origin. And then now as I tilt the sketch by using the view cube to rotate it, you can clearly see how the plane we're drawing on is farther away, or is some distance away from this plane in the back. And then if I want to go back to that view where I'm looking, that was the front view, I can just double click on the view cube and it'll snap back to that full-on front view. So our sketch tools, they're pretty straightforward. We've got a line. For the line, you click somewhere and then you start drawing, and it just will connect points. And again, once you close a feature, it's going to turn blue. It's going to do shaded blue. You need to have a closed feature if you're going to use the extrusion tool or the revolution tool. Any of those 3D, those 3D solid tools require a closed sketch or a closed 2D shape so that it can then make it into a 3D shape. This particular, once you've created something, when it's blue, so it's shaded in blue, meaning it's closed. The lines are blue, which means that they exist, but they are not defined in a certain place or location. So I can grab a blue line and I can drag it. I can drag a point and I can drag it. And I can do things like this to modify my shape. If I can drag a point, if you see when I hover the mouse over it, there's a little shape there. This is the constraint up here, the coincident constraint. And really what this means is that the point of this blue line occupies the exact same space of that point on this blue line. In other words, that's how it's closed, right? These two lines, each line has a point at the end. This point is really the point of two blue lines together, right? So that's what this little symbol means. This means coincident. So if I had another shape, let's say we made it just an open shape, and you can either stop drawing a line by clicking the little check mark here or by clicking escape, and then it'll stop, right? So if I go now and I look, right, so like this point again has the little coincident constraint, but this one does not, because it's not connected. Now I can actually manually put a constraint. So I could go over here and I could click the coincident constraint button, And I could click this point, and I could click this point, and I have now, defined to the computer, hey, these are really the same point. These points occupy the same spot in space. And so now if I mouse over it, you see that I have the little constraint there. Some of these other constraints, so I could take this coincident point and I could make that here on this triangle, and I could choose the origin point of my sketch plane. And so if I do that, it has now moved my triangle over to this this little spot. And so it has now told the computer that this point exists in the same space as the origin. And now if I go and mouse over it, you'll see that there's two coincident constraints on it, because there's one to each other of the point, and then one to the origin. And then some of these other constraints, like this one here, is a horizontal and vertical constraint. So like this bottom line is at some angle. If I wanted it to be perfectly horizontal, I could click this constraint and I could assign it to this line, and it'll make that line perfectly horizontal. And then as you see, there's a little, it's like a little saw blade, but this is the symbol for, being the horizontal constraint. And if I wanted to, so like right now, if you look, this bottom line of the triangle is turned black. And that means that it is now constrained enough that it cannot be moved. If I click on this line and try to drag it, I can't. I can't drag it because I have now assigned it, to be constrained to horizontal. So if I try to move it away from horizontal, it won't work. If I didn't have the coincident constraint with the origin, so I'm clicking that constraint, I'm going to hit the delete key to delete it. This blue line, this line on the bottom has now turned blue because now it's no longer defined in space. And if I click to grab it, I can move it up and down. So it still stays horizontal because it has the horizontal constraint, but it no longer has the position of having one end be at the origin constraint. Does that make sense? So I'm gonna, oops, not that one. I'm gonna go back to this one. Let's make that start, go back to the origin like it was. So let's do a dimension here. So if we do the dimension tool, I can now draw a dimension between that line and this horizontal line. And let's give it around 65 degrees, right? So now I have defined this line as being at an angle 65 degrees from this one. So it has turned black because, again, it is now constrained. The start point is at the origin, and it's at this angle. So it's black, but this blue line is still blue because I can still drag this and pull it wherever I want because I haven't constrained either a distance, this line is from here, or I haven't defined a length for either of the other legs of the triangle. So in other words, this point on both of the black lines is constrained, but these points on the other ends of the black line are not constrained. And I could even grab one of them and, I could drag it and change that angle a little bit. Sometimes when you're drawing, it's a best practice to make sure that all of your sketches are fully, or all of your elements in your sketches are fully constrained, just because it prevents anything from changing or moving unexpectedly further down the line. So one of the things you can do is, all right, if I give this one, let's say we give this leg a dimension, right? I give that leg a dimension, and it's still not fully constrained, right? So you might think, we've got an angle, we've got this as parallel, we have this point constrained, but I've given this a dimension. Why is it not constrained? And if you wanted to test anything blue, you could move around. So if I click on this blue line and start moving it, it's like, okay. So it is keeping it at 121 millimeters, but it can kind of move all around, right? So it's following its rules. So if you were trying to kind of finalize a sketch and put all, make sure that everything is black and everything is constrained, If you are unsure what constraints are needed, whether they're dimensions or these constraints up at the top, you can click on anything that's blue and try to move it, and then by moving it, hopefully you'll be able to get a sense for, okay, what needs to be defined next. And so for this one, we can use let's do the perpendicular constraint. So this one, we will define two different lines, and it specifies that they must be 90 degrees to each other. So if I do this line and this line, there, now we have a 90-degree corner, and that is designated by this little T shape, the little right angle shape. And so now this is fully constrained. All three sides are black, it's blue in the center, and if I try to select a point, I can't move anything. It is now fixed in place. The computer now knows exactly where it is. Is that making sense?
Yes, sir.
All right. So if we are going to draw a little chair shape, let's just pan this over just a little bit more in the start, and we can start drawing some lines, and we'll do, let's start drawing a little basic chair. And it will give you options. So as I'm drawing a line, if you see it starts off, this is that horizontal constraint. So because I'm drawing the line pretty horizontal, it's assuming that I want a horizontal line. So it's giving me that constraint. If I start going off axis, it takes that constraint away. So I can let it draw it. I could always assign it later. I could always delete it later. But we'll do a simple little legs and a base. Maybe come up for the seat. Maybe go up for the back. A little spot off. And go back down to close it, right? So we've now created our shape. And again, this is all pretty free form. We can move stuff around, and it'll do things however we say. But we can now start defining it in space. And so one thing, let's see, we might want to, I'm just going to say, let's see if I can make it do something wacky here, right? So if I take this corner, and if I assign this corner to the origin, I wonder if it'll move the whole shape, or if it'll try to just move this one point. Okay, it did move the whole shape. Sometimes you go to move stuff like that. If you have some things constrained and other things not constrained, it'll start warping or making your shape a very new structure, because it thinks that some things you want to have stationary, and it's like, oh, you want this point over to the left? I'll move it there. And then it, creates a wacky geometry. So if we start, let's, there's a few other constraints that I'll show you. So if you see, there's a whole bunch of these equal signs, these parallel lines. That's this one here. So this is saying that it's a parallel constraint. So right now, we've got this horizontal line is parallel to this line, which is parallel to this line, which is parallel to this line, and this line has the horizontal constraint. We could do this all with horizontal constraint symbols, or we could do it by the parallel symbols. There's, as usual, there's a lot of different approaches and a lot of different ways to do this, but we can keep it this way for now. So I'm going to go to the dimension tool here, and let's start just putting a dimension or two on to start constraining it. So we'll give it that. We'll make it a round number. We'll make this foot the same. Again, like moving the pieces around or the constraints around with the dimensions, if I wanted to then change a dimension, I can click on this dimension or double click on this dimension, and I can give it a completely different number, and it will make that update on the fly real time and adjust other things to it. So let me put this back to 14. So if you notice, it's keeping this corner right here stationary. So if I make this 30, it has increased the slope of this line. If I make this 300, it increased that slope a whole lot. if I go back to 14, whoops, so look at that, right? So there's a good example, right? So I made it 300, it pulled that point way over here. I've now made it 14 again, but instead of going back to the way it was, it kept that angle. And, so this is why constraining things is good, because otherwise you go to make a modification later and you might totally screw up a geometry with something wacky like that. But I can, grab this point and bring it back to where it was. But I was going to say, if I started by putting an angle between here and here, let's say it's a 98, let's make it 100 for a round number. And now if I was going to change this 14 down here, it's going to try to, keep this angle the same. But now if I make it 300, right, it made it thicker like that. And let's see if I move it back, if it's going to do something similar. Okay. So it's a little happier that there's, those extra constraints. One thing, if you noticed, when I gave it this 100-degree angle up here at the top. Hey, Kevin. Good to see you.
Sorry I'm so late.
That's okay.
Long, tedious finance committee meeting.
You'll get to watch the recording and catch up afterwards. So this 100-degree angle, when I created it or when I typed it in, it moved this part of the leg of the chair down a little bit. There's a few ways that we could address this using the constraints. One way would be to use the coincident to say that a point on this line falls on this line. Another one we could use is there's a constraint over here, collinear, which basically means roughly the same thing. Two lines fall in the same space. But I'll use the coincident one. So if I choose one corner of that point there, and if I choose this line, then it'll snap up to that location. And now it actually turned black because it's happy. It knows that that this is now somewhat constrained. Like the ends aren't constrained. I can still grab it and move it around this way, but I can't move it up or down, and I can't make it longer because the 14 millimeters here constrains that length. And so let's see, we'll give this, before we go up here to the top, we'll show you some of the other tools that you can use. This is a fillet tool. You have a trim tool, an offset, and there's a bunch of different other ones here. You can do chamfers and some other things, but the fillet tool is nice. Like let's say we wanted to make a little rounded arc or corner here. I can click that point, I can type in a number, say 10, and if I actually click again, I can do multiple of these. So if you have a shape that has lots of triangle points or square points or rectangle points and you want them to be radius, you can select them all, type in a number, and then it'll make it that size. And if you look, a few things popped up here, right, from doing it. And that was these symbols, these constraints. So these are the tangent constraint. And if I click it, you can actually, if you forget what some of these symbols are, if I clicked it, you see over here in the lower right-hand corner, it actually says tangent constraint. Right, I can click on the parallel and it tells me parallel constraint. And if you notice, when I click this parallel constraint, it actually also highlighted this one up here at the top. So this particular constraint is saying that this line is parallel to this line. If I click this one, it is saying the line down here is parallel. If I click this one, it's saying that the line down here is parallel. And I just actually realized, I don't know if you saw this, but when I had already selected this point, when I selected the radius tool, so it made 3 radiuses. It made them the one that I had selected down here, and then these 2 other ones. And so if you look, there's another very similar looking constraint. It's like the parallel one, but it's horizontal. This is an equal constraint. So it says equal down at the bottom. And so it's highlighting this radius. And what this is saying is that I have this radius dimensioned as 10 millimeters. These other radii are equal to that one. But I don't want this to be rounded here in the corner. So I'm just going to click on that and hit delete. and it's going to vanish. So now my shape is no longer shaded in blue because it's no longer a closed shape. If I want to close this back up the way it was, I can actually use, there's a tool here called Extend. Extend will let you select a line, and it will continue that line until it would cross the next element. So I can continue that line. I can then zoom in a little bit and click this little segment here and do that line. And then now it has shaded in blue again, because now my shape is completely closed because I extended those lines. And if you look, it's allowing me to, even extend these lines further, right? I could extend this line further and this line further, and I've made a point and another blue shaded in area. If I wanted to get rid of these ones, I can click the trim tool, which is the scissors, and I can click on a segment that I don't want, and I can delete it. And this trim tool, like you can either, so let's say I'm just going to draw a random line here. This trim tool, I can either have a piece hanging out in space that I want to trim back to my object, or I can snip out a specific segment. So it's looking where this line is crossing all other lines and is allowing me to either, delete this segment or this segment. Or I could actually, delete them both by using that trim tool. So the trim tool is handy. The radius tool is a pretty handy one. Now that we took away our dimension for the radii that was this corner of the foot, I can now use my dimension tool, and I can give this a radius. Let's make it a little bigger. I'll make it 15. So it made that radius 15. And then if I wanted to, I could use that equal constraint, and I could make this one the same as that. Or, if I didn't want to do that, I could dimension it itself. I could either put a dimension on and dimension it itself and make it 15, or I could make it something different. You could say, let's make that one 20. And so as you do this, it's going to, start being constrained. I don't have anything else turning black yet, but we'll put a few more on. So this is, I think this little segment here, let's make that segment 15. Let's give this part of the leg an angle. We'll make it 80, so it's a 10-degree angle. And so again, we can start seeing that, part of it is now black, right? So the computer's happy with the placement of this line. If I try to click it here, I can't move it. Although if I clicked up here, that line could still be longer or shorter. Now, instead of giving this a defined length, this line, I might want to give it a constraint off of this top line here, right? So I can do like a separation from there, let's say 25. Now, these two lines are now a fixed distance apart, but it's nothing's black down here yet, because if I grab this, I can still, it's still letting me move all of that, right? So there's other things I can do to constrain it. Let's put on a dimension. Let's make this leg the same. So this leg, actually, this will be a good thing to do, right? So this leg, let's say I want it to be the same angle as this one. So it'll be 80 degrees from horizontal, or 10 degrees from vertical. I don't have any really good vertical lines on this drawing to dimension from. So one of the things I can do is I can create one. I can create a line. It could be most anywhere. It could be on the origin. It could be on a leg or a part. So we'll make one here. So if I make it so it's straight up and down, and hit escape so that I don't have a tail on it, I can select this line, and over on the right on the sketch palette here, there's an option for construction. If I click construction, it makes this line dashed, which means it's a geometry, but it's not a geometry that's going to be part of a closed element that I can use for 3D construction. I can give this a constraint. I can give this one a vertical constraint. Oh, actually, never. It was unhappy with that, right? So if I click that, I got an error message in the bottom. Sketch is over constrained, and I realized what it is when I drew this, it created a constraint of perpendicular to the bottom, which I'm going to delete that and just put in the vertical one in case we ever modified that line. In other words, this one is now constrained more to the outside world and not to another element in the sketch. But now that I have this line constrained as vertical, I can now give a dimension to it for that inside part of the leg and say, let's make that 10. And then there you have it. And again, it went kind of wonky on me because it tried to keep some of the other geometry. I can, grab this and kind of bring it back to where I wanted. Or, I could type in a dimension and do it that way as well. And let's say, so we've got this. So now this front leg these two lines would be parallel because we've got, 10 degrees here from the 100 and then 10 here from the 80. The other thing you can do is sometimes as you scale or you zoom in or out on your drawings, as you create dimensions, sometimes dimensions will lay over each other and get a little messy. So you can click on the actual, if you click once on the dimension number, you can drag that number around more for your ease of view. And then again, if you double click on it, you can then type in or change the value. Some more of the sketch tools I want to point out is, let's, actually this will be a good one. Well, let's do an offset line. This will make it a little bit more complex. This is an offset line. This one I actually like using. Let's say you're going to make something out of sheet metal or something that's going to get like plasma cut or laser cut out, and you want to kind of skeletonize it a little bit. If I click the offset tool, it's asking me over here to select a curve or the sketch point. So if I choose this, I then have a slider. I can then either make the offset, inboard or outboard. I can either make it outside or I can make it inside. But let's make it inside by 5 millimeters. So I'll do -5. And so it draws that. So it draws another set of lines. And interestingly, if you look at it, some of these lines are black because they are being referenced off of previously satisfactorily constrained lines, so it would carry that over. But what I want to do is let's make some radii in here, and we'll make this in 2 pieces. We'll make a front half and a back half. So I'm gonna draw a little line here, and we'll make it right here from the center line of the circle, right? So we'll go from there up to here. And I'll make another one here. And then I'm going to trim out some of those pieces. So I'm really playing with 2 separate interior pieces here. I'm going to use my radius tool. And I'm just going to click a whole bunch of the points. We'll see, actually, I'll leave that one be for now. I'm just going to do interior points. So this is actually one that will get a little funky. I'll show you. Actually, both of these will. So I'm going to do this by just creating the points. It draws a whole lot of constraints. And if you look up here in this corner, like it did something real funky, right? Because it did one radius, and then I clicked to do the other radius, but there wasn't enough room for that 5 millimeter radius. So the computer, to make itself happy, made the radius go in the other direction to give itself room. That's not what we want. So I'm going to trim these pieces out, get rid of them. But what I am going to do is I'm going to, under create, I can create my own arc. Instead of just using the radius tool for an existing corner, I can say that I want to make a radius, from this point to this point, and I can, give it a size or a shape. It will default to, if you line it up, that's a tangent constraint that is popped up on the right side there. So I can let that tangent constraint exist. I can give it another tangent constraint between here and here. And so now it has made it so that this radius is tangent to both of these lines. And then if I wanted to change it size-wise, so one thing I want to do here is I do just want to make sure that it knows that the distance between these lines is going to be 5 millimeters, because as I've modified this, I've probably lost some of my offset constraint. So 5, 5. I'll zoom into down here. This one 5. And yeah, I have that one 5. So now with this dimension tool, if I zoom into where I have my radius up at the top here, I can now put a dimension on this. And as I change this number, if I make it 5, it didn't actually do quite what I expected. I thought it was going to move this point down to make it 5, but it didn't. What it did is it made that leg thicker, or it actually moved the top part of the leg over here. So let me undo that. And I'm going to give this side of the leg an angle. It stays put, because what I wanted to do is I wanted this radius to move downward as I changed its dimension. So we'll make this. So this is saying it's over constrained. So something on here is not letting me move this like that. And oh, I think I might know what it is. Is it here? So we've got this arc. Oh, because I have it planned here. There we go. So that made it wider, but if I now move it down, it will make it thin again. Because that was my original intent, was to bring this part of it inboard some. Bring it in a little bit more. And the other thing it did, so I showed you the funky geometry it made when I selected both of those points to be radii. It did the same thing down here. It made crisscrossing, made those radii crisscross over each other. So again, I'm going to trim those out. And we will draw, we'll create our own 3-point arc between this point and this point. That side's tangent. I'm going to make this side tangent. And again, it's blue because it doesn't know where it exists in space, right? If I grab it, it'll let me go up and down. The last one I did by defining a dimension to this actual arc, to that radius. But this time, let's do a little differently. Let's do from the center point to this line and do it that way. So that's another way to constrain its position. Again, I said that if you drag something, you can click on something and drag it around and kind of get a sense for what direction it moves, and then that would be the direction it would need to be constrained. So we've obviously sketched a whole bunch on this. We've put a lot of dimensions on. We've created a lot of different things. And so for now, let's just, we'll finish this. We have 3 closed-in geometries, right? We've got the outer profile of the chair, this inner portion, and then this inner portion. So if I do finish sketch, it shows our sketch on the plane where we created it. And now I can use one of the tools, like I can use the Extrude tool. And I can choose, if I click this profile, you'll see that it's shaded blue, only that outside profile, which for this chair, I think that's good. Let's do that. If I wanted the inner profiles, I could click them as well. And then now, it would extrude the whole thing like that, so it's a solid. And if you look over here on your menu for your extrude menu, you see that 3 profiles are selected. But if I go back and I unselect this one and I unselect this one, you now see that the chair has hollow parts, and it says here that only 1 profile is selected. And then the other parts of the menu here, the extrude menu, is we can tell it that we're starting from our profile plane. We can have it start offset from that plane. Typically, I will just let it start from the profile plane. I think it's a general best practice to have your sketches be there, because if you need to move stuff around later, it's a little easier to redefine the plane than to try to remember that, oh, I have this part, 10 millimeters offset from a sketch, and this one a different offset from the original sketch plane. There are instances why you would do that, but general best practices is I try to always have my sketch or my solids start from that sketch plane. You have a direction. Right now, the direction is one-sided, so I can either go this way or I can go this way. If you do two-sided, I can make it so that each side could go different amounts. So I could go negative, 10 millimeters this way, 40 millimeters that way. Or I do have an option for symmetric. So symmetric means that it would go out the same directions from both sides of your sketch plane. There's also a distance. So I right now I'm typing in a distance. You can have it go like up to a body or up to a face on a body, or you can type it in for the first geometry or two you create in a whole model. You're not going to have much else to reference off of, so distance is going to be how that's probably going to start. And then this is the distance here. It's the same. You can type it in here. You can type it in here, and you can actually give it a taper angle. This would be like if you were going to create something for plastic injection molding and you wanted it to, so let's say if we made this a little thicker, and let's say we gave this a taper of 2 degrees. And now if we click OK, it should give this a little bit of a taper when it creates. So, oh, I see what it actually did it in both directions. So if I look up at the top here, it's like a little bit of a V shape, right? If I look up at the top, it created it as a little bit of a V because it went towards the sketch plane. If I right click on extrusion, the pan mode, right click on extrusion, I can then go to edit the feature and I can go back to all of these parameters. So I can say, actually I did not want the taper. We'll make that 0. And maybe actually I did want it a little thicker. So we'll make it 30. And so there we've got the sketch that we created and we drew it out. So I spent a little longer on that drawing, that sketch, than I had initially intended, because I wanted to go more, talk also about, if we did another sketch to reference this plane. I don't know, do you want me to dive into that now, or is this, do you think, a good stopping point and let everyone digest kind of the sketching and the creating sketches and maybe pick up something like this next week?
It's up to you, man. I mean, there is plenty to practice and learn.
Okay.
Yeah, I think
How about we leave? Yep. Was that you, Joel?
Yeah. This is a good stopping point too. So.
Yeah. How about before we stop, because I did share this chair model with you, this other one that I did. How about I just step through this for just a few minutes? So if you open up the model yourself and you want to play with it or look at some of the sketches, you can kind of see what's done here. And I can probably start by, if I turn the timeline all the way to the back and if I start playing it, you'll see a little animation of where I'm creating some geometries. There's some reference geometries, creating the sides, creating planes for the front brace and the back brace, and then creating my the back braces on the back of the slats. And then in fact what I did is I created a sketch from each one so that I could I actually laser cut it. I have a little laser cutter, and I don't know if you still have my camera view open. See, I can probably have this real fast and make it wait. Do you see on my camera screen here, I got my little chair. So I made this out of cardboard on a little laser cutter, like a little laser engraver. So I was able to draw it out, make it, see if it assembled, and put it back. So
Very nice.
yeah, so to kind of test it out. All right, so let me just pull back up this window. So yeah, so this chair. So I started off, by creating a lot of different geometries, a lot of reference planes and angles. So let me pull this all the way back. I turn on my construction stuff, right? So I actually started making. I didn't go back quite far enough. I started by making some planes that were offset from the origin. And then what I did is I made two axes. So I made an axis from these two vertical planes and this horizontal plane, because then from those axes, I could then do an angled plane, right? So I was able to create a plane here at a 4-degree angle. So it was 4 degrees from that vertical one. So then started creating my sketch. They say it's kind of a, medium complex sketch there, but it's on that plane that's at a 4-degree angle. And so if you look, you can actually see this line, this red dotted line here, and this green dotted line that's real faint. That's actually, the overall origin. But because it's at an angle, right, it's tilted away because it's that 4-degree angle. But I drew the SketchUp. It's got some radii. It has some angled measurements. It has regular linear measurements. I think I actually did this in inches. It's got some constraints. It's all black, so it's fully constrained. And so then I use that to make my first extrusion, which was the side of the chair. I then created a plane, or I made a copy and paste of it. So by making the copy and paste, it allows me to keep this one as the master, this side is the master, and this side is a copy of it. So any changes I make to side 1 automatically get made to side 2. So let's see. Oh, and then I actually have to angle it and put it in the right position. See what I do next. So I started then by making, I think, this front brace. Let me turn off some of these construction planes for a minute and that origin. So then this front brace, right? So then I was able to, I made the front brace here parallel to this front surface of the legs. So it's actually really, because these legs are tilted, it's really, I made a plane from this line and this line. And so from that plane, I was able to then create an offset plane and make this sketch. And so this sketch, it's busy because I did some little features here. I in all of these sharp corners, I actually made little radii, thinking that if this was ever made out of like a piece of plywood, out of 3/4 inch plywood, if it was cut with like a 1/4 inch router bit, the router bit cannot make a sharp corner, so the router bit would have to dip in and then come back out to make the square corner. So every sharp corner, I went and dimensioned a little feature here. That basically what I've done is I created a 0.25 arc, and then 0.25 radii around it, and then it's got tangent constraints, so that from this line to the arc and everything, it's a fluid flowing tangent geometry. But that, when you zoom out and you see all this cluster of blackness, that is trying to define those things. But other neat things that I did, so if I rotate this a little bit, so first of all, you can see that because everything's at an angle, right, the green line here, which would be kind of my true horizontal to the origin, or to this leg, but because this leg is tilted, everything here is at a little bit of an angle, right? So that's why the grid is kind of askew from drawing this, because I drew this relative to the tapered sides and not to the origin. But if you look here, if I tilt this a little bit, you can see the two sides of the chair. And what I was able to do, if you look at this purple line, there's 2 purple lines here. These purple lines are a projection. So I was able to select one of the edges of the chair and say, okay, this edge does not exist on my sketch plane, but please line it up and put it on my sketch plane so I can use it as a reference geometry. So then, when I had those reference geometries there, I could then figure out, okay, I want my tab and my little hole in my tab to be, on the far side of that reference line. And so that's how I made it so it would stick through. And then if I finish this, and then I, extrude it to give it a little thickness, and so you can see that, this shape now, nicely kind of protrudes through those sides there. And if you look, like this shape goes through the sides, but there's not actually a hole in the side yet. This side is still solid. If I hide this, right, there's no hole there. I didn't create those holes until later. I actually waited until after I had created I made the base, the seat base next. That's here. And then I created the back piece here. Then I think I went and started. So yes, if I go to this sketch is on my side again. And basically what I did was using that purple reference geometry, I pulled those tabs. I said, okay, let's use, zoom out a little bit here. Let's use the top, side, the side and the front and the back of these tabs. In fact, if I hide this for a moment, right? So I was able to use the defining features of these tabs to create my references, which are the purple lines. And then I was able to then, draw my little dog bone shape around the purple lines and then give it, right, so I ended up giving it 10,000ths of an inch clearance, right? So that I made my sketch lines 0.01 of an inch outside or away from that feature in the other part. So that way when if it's ever cut out, there'll be enough clearance, it'll slide through. There's no corners, so it should slide together and mate properly. So after I created this sketch, then I created the cutouts for it. So now if I turn off, these other parts, you'll see that now I have those holes in my side pieces. So I was making the parts kind of in parallel or tandem, kind of do the outline of my chair sides, make what goes into them, and then go back and then make the cutouts for those other pieces. So if you play with this model and you step through it, you will see some of that creation there, but that was my logic. And then the rest of it, the same thing, I added the back braces using the same kind of technique. I created some reference planes, and then, I created each sketch for each brace here. And then I had to figure out, okay, where does this top part of the back, because it's at an angle, where is it going to intersect the my plane? And if you look, you can see that the distance of these little tabs on the side, decreased as you go down, because I kept the same width, but the backs of the chair, tapers in at the top. So that hopefully gives you enough ammunition to start, if you download this model, to start playing around with it. You can modify stuff or just look at it. And then at the very, very end, I created a little wedge. So I figured if it was, going to be cut out, I could make this little kind of wedge shape that has a little bit of an angle, and you would kind of hammer it in place, and that would hold it all together. So I only made one of those. I could have made copies of it now and copied it to all the other locations, but I more just wanted to create the geometry, and then then I cut it out on the laser engraver. So there you have it. So I think that hopefully has covered enough for today. I'm going to stop the recording, and hopefully you now are armed a little bit better with the knowledge of Fusion.
Fantastic, Dan. Thanks very
And
much.
dangerous.
You're very welcome.